But suppose we take a general tree diagram, okay, just say with two events like this. Let's say we call the first one event X. Something happens, okay, we call it event X. And then after that something else happens, we'll call that event Y. Alright? So what can happen? We either get X happening with the probability that X happens, and X will not happen. So we can write that X with a little dash by the side, probability that X doesn't happen. And then for our event Y, we're going to find that either Y happens or it doesn't happen. It happens or it doesn't happen. But it's dependent, say, on the previous event happening. So we'd write this, the probability of Y given that X has just happened. And then this would be the probability that Y doesn't happen given that X previously happened. And if we come down here, X hasn't happened, but we might have Y happening. So the probability that Y happens given that X didn't happen. And finally, we've got the probability that Y doesn't happen given that X didn't happen. And so we've got all the possibilities in this particular scenario outlined in this tree diagram. Now the reason for doing this is that suppose we wanted to work out, for instance, the probability of X and Y happening. That would be to take this branch through here and to multiply this probability with this probability. So if I wanted the probability of X and Y to happen, okay, then this would be the probability of X going along here multiplied by the probability of Y given that X has occurred. So I'll drop the times sign and just write the probability of Y given that X has occurred. And this is something that we should, or you should be familiar with so far, that when you go along a tree diagram you multiply the probabilities together. Now there's going to be many questions where we're asked to find the probability of something given something else. So let's rearrange this equation to make this the subject, the probability of Y given an X. Okay, so if we rearrange this, we would divide both sides by the probability of X. And so that would give the probability of Y given X, okay, probability of Y given X, is equal to the probability of X and Y divided by the probability of X. Now in general, we're not going to have X's and Y's, okay? We might have A's and B's. So let's just see what the general formula then would be when you've got the probability of one thing, let's say A, given that another event has occurred. Well, according to the formula, okay, we can see that we have Y given X was the probability of X and Y. Well, that's going to be the same as the probability of Y and X, for instance. It doesn't really matter what order you do this, okay? So I can say that this is the probability that these two events occur. So I'm going to write that the probability of A and B. Alright? And then it's divided by the probability of the given event. As you can see, the second letter here, X, this was in the denominator here. So in this particular case, it will be divided by the probability of the given event, which is B. Now in some books, or formula books, there's a symbol that we can use for A and B. It is an upside down U, often pronounced the intersection. Let's just write this down. the probability of A and B can often be written by that upside down U. Alright? And then it will be over the probability of B. So, what I want you to do is to try and learn this particular formula, because you're going to find that you're going to need it a lot of times in questions on more advanced probability.